Hello everyone, today we'll be solving detect a cycle in a directed graph. So welcome to Minutes Programming and get right into the method number 2 BFS. If you have not seen the video for the method number 1, I suggest you check that out as well. So this will be solved using a algorithm which is known as topological sort or topo sort. So that is kind of the prerequisite for this question. So let's just go right into the dry run of the question. So I have created an array to save some time for the indegrees of each and every vertices on the graph. So let's just start the dry run right away. So in the topo sort, we'll add all the nodes which indegree 0 into the queue. So right now we have 0 in the queue. Let's just say this is a queue. So we take out 0 and then we see, oh, 0 points to 1. So we'll remove the indegree of 1 by -1. I mean, like, we'll reduce the degree of 1. So now the indegree of 1 becomes 1. Now, there is no other element inside over here which has an integrity 0. Since it does not have an integrity 0, it will not go into the queue. Since it's not in the queue, we can't process any further. So basically, the topo sort right now is just the number 0 and nothing else. Since this is not equal to number of vertices, we can definitely say that the topological sort algorithm fails. And it failed. Why? Because there was a cycle in the graph. So that is the reason we can use topo sort to find or detect a cycle in a directed graph, because topo sort only works in directed acyclic graphs, a DAG. So just so you understand that if there was no cycle, everything would have been fine. I have another example. So there is no cycle over here. You can see no cycle, and I've again mentioned the indegrees right here. So let's start. In the queue, we'll have all the vertices with indegree 0. So queue will have a 0 and a 4. So we'll take 0 out of the queue and add 0 to the topo sort. Topo. So 0 taken out of the queue, and so we'll see. 0 is, 1. Element number 1. I haven't mentioned the 0 vertex. So we take out 1 from the topo sort. So 1 points to 2. We'll reduce the degree of 2 by 1, so which becomes 1 now. In degree of 2 is now 1. So now 4 is the only element which has in degree 0. So we take 4 out of the queue and we add 4 to the topo sort. And 4 points to 2 again. So in degree of 2 goes from 2 to 0. Now we add 2 to the queue because the in degree of 2 is 0. Now we take 2 out of the queue and we add 2 to the topo sort. 2 points to 3. In degree of 3 is 0. Now 3 comes into the queue. Now we take out 3 from the queue and 3 to the topo sort. 3 does not point to anything. At the end, this is our topo sort, which is 4 vertices, which is actually equal to the number of vertices in the graph. Hence, you can tell that there is no cycle in the graph. Now let's just discuss the time complexity and the space complexity of this algorithm. The time complexity of topo sort is big O of vertices plus number of edges, and the space complexity of the topo sort is, to create this array of in degree is big O of the V. So that's it, guys. That's it for the BFS. Let's meet you in the next one.